Okay, in this lesson, we're going to be talking about pressure conversions, and we'll need a calculator for today's lesson. So, you'll only do these pressure conversions when we're talking about gases because remember, they're the only ones that have pressure for it. So, just to reiterate, according to the kinetic molecular theory, KMT, all matter is moving. Now, gases are constantly moving, colliding with other particles, the walls of containers, and even us as they're going through it. So, gas pressure is the result from the force exerted by gas colliding with those objects. Remember the walls, other gas particles, and even you. So, do you remember what we call the device to measure gas pressure? Awesome. It's the barometer. And the barometer was actually invented by an Italian physicist, Evangelista Torricelli, in Italy in 1643. Originally, gas pressure was measured with mercury in a basin, and it was known as the barometer. So if we look here, we'll see that we have our mercury down here in our basin. And what they actually did is that they would have a vacuum tube upside down. The external pressure, aka the pressure on the outside, depending on the day, the weather, and the altitude, would be pushing down on this basin of mercury, which is liquid metal. If the external pressure pushed harder, they would see that the column of the mercury in the vacuum tube would go higher for it. And so they were able to measure the pressure in millimeters of mercury. Now, they eventually named millimeters of mercury in honor of Torricelli, and a lot of times you'll see it just as Torr because he was the inventor of the barometer, aka a device to measure pressure. Now, these are the following pressure conversions we're going to be using in class. We have our 1 atm equals 101.3 kPa. We have 1 atm is also equal to 760 mmHg or torr, and we have 101.3 kPa and 760 mmHg torr. Now, we can use all of these for conversions to help us convert between one to another. So if we're given ATMs, we'll be able to convert to kPas or mmHgs for it. So remember, if we're doing conversions, we're always going to start with our given. And what that means is that we're going to set up a two-step conversion. We're going to start with our given here, and then we're going to use one of these conversions as our conversion factor. Now, depending on what we are given is whether we're going to use our first, second, or third one. And we'll do a few examples. Now remember, units have to go on the opposites to cancel out, leaving us with our unknown unit here. Now, when you're ready to solve it, don't forget you're going to multiply and get a number on the top. You're going to multiply and get a number on the bottom. And then to find your final answer, you're going to divide top by bottom. Don't forget to round to your sig figs as per the given, and then put your unit at the end. So, are we ready to try one? Well, I hope so. So example number one, it says, if you have 99.6 kPa, how many ATM would that be? So first we have to decide what our given is. So we look for the number in the problem and we see that we have 99.6 kPa. So I'm going from kPa to ATM. So we notice we're going to be using our first conversion here. So I'm going to cross out the other two. I don't need them. So if I have kPa as my given here, I need kPa on the bottom, and my unknown is ATM. So if I find kPa in my conversion, I look before it, I see it has the number of 101.3. If I find ATM and I look before it, I see that it has 1 ATM. So I multiply the top and I get 99.6, and I multiply the bottom and I see I get 101.3. So this is where we need our calculator out. So right now in your calculator, you're going to do 99.6 divided by 101.3. And we get a very long decimal. I got 0.983218164. Very long, but we know how to round it as per our sig figs. So notice that kPa and kPa cancels out, so my final unit is going to be an ATM. Zeros to the left are placeholders, so I'm going to carry it down. And then we see that 99.6 has, yeah, 3 sig figs. So count over 1, 2, 3. Will 2 round 3 up? Nope, so we're going to have 0.983 atm. And that's how we do a pressure conversion, and we'll need these potentially when we get to gas laws in the next part of this unit. Okay, you might want to pause the video, try example number 2 on your own, and then hit play when you're ready to go through it. Okay, you're back. We're ready to go through example number 2. If you have 985 mmHg, how many atm would it be? So remember, we're going to start out with our given first, and then we're going to look at what conversion factor we need. So we're going to have 985 mmHg, and we're going to be going to atm. So we'll notice that's going to be our second one. So I can cross out the top and the bottom. I don't need it for this conversion. So I need my mmHg to end up on the bottom and my atm on top. So I find mmHg, and I'm going to see that it is 760. Thanks, Evangelista Torricelli. And then I'm going to find atm. I look in front, and I put 1 here. So we're going to have to divide on this one again. So let's multiply the top. Awesome, we get 985. Let's multiply the bottom. Awesome, we get 760. So we're going to do 985 in our calculator divided by 760. So we get a long decimal, of course, 1.296052632. So how many sig figs are in 985 as our given? Awesome, 3. So we go 1, 2, 3. Will 6 round 9 up? It does. So we just don't have 1.3 to give it 3 sig figs. We're going to put a 0. Okay, mmHg cancels out. We're going to have atm. Okay, our final example. Example number 3. If you begin with 4.5 atm, how many kPa would that be? So the same way that we did before, we're going to start with our given. Awesome. That's our 4.5 atm, and we're trying to get to kPa. So we'll see we actually use our first one. We don't need the other two here. So let's put our 4.5 atm. We need atm to go on the bottom, and we're going to put kPa on top. So we find atm, we see that has a 1, and we find kPa, and we see that that's 101.3. So now we're ready to solve. Notice that atm and atm cancels out, and both of the numbers on the bottom are 1 and 1. So we're going to be multiplying in our calculator right now. So 4.5 times 101.3, and we get 455.85. Go back to the given, that 4.5, and how many sig figs does it have? 2. Perfect. So we're going to count over 1, 2. Will 5 round to 5 up? Yes. Now our answer is just not going to be 46. What can I put in this place that has no significance? A 0. Now make sure you don't put a decimal. That decimal would make it significant. So we're going to have 460 kPa as our final answer. So this video just took us through our barometer, how we got our pressure conversions, and then showing how to do those pressure conversions. So thanks for watching.